Hi. In this episode, we are going to divide complex numbers. So let's just dive in straight into an example. Okay, here we go. Our example then is going to be, let's use the numbers we've been using. How about that? So I had a 3 minus a 5i divided by a -1 minus 2i. Now, this is kind of an interesting catch that mathematicians have used. And the idea is that if you multiply by a conjugate, multiply by a conjugate, a difference of squares, this is the key idea, a difference of squares results with no middle term. And that's the important part, with no middle term. Because remember earlier we said that when you multiplied a complex conjugate, the result was the middle term went away, and then because you'd have an opposite with the i's, and then the last term was an I squared. But that became a -1, which turned it into a real number, and so then you could combine. So let me show you what I mean. You've actually been working with conjugates for quite some time. So if I give you x plus 1, so let's rewrite this. Let's do it this way. Say I give you, I'll give you a number, and then let's write the conjugate. Okay, we'll come back to our example. Don't worry, I haven't forgotten. So if I give you the number x plus 1, all you do is you just change the sign. So between the two terms. So its conjugate is x minus 1. If I give you the number of 2 minus a, you change the sign between the two numbers so that the conjugate is 2 plus a. And notice that if I was to distribute x plus 1 times x minus 1, my result is x squared minus 1. Well, let's do that result. If I was to distribute 2 minus a with 2 plus a, my result would be 4 minus a squared. Now, all these are differences of squares. So now let's try the one at hand. What if I have -1 minus 2i? Well, the conjugate is simply change the sign between the two numbers. So this becomes -1 plus 2i. So just to show you how this works, let's take a moment and let's distribute this. So we're going to start with the -1. So distribute the -1 through the parentheses. So that's going to be -1 times -1 is 1. -1 times 2i is minus 2i. Then we change colors. We go to magenta, and we distribute again. So -2i times a -1, and then a -2i times a positive 2i. So that's going to be plus 2i. -2i times a 2i, we're going to have a -4i squared. So now let's put everything back together. When I do this, I have a 1. These are opposites right here. These are opposites, so they're just 0. The sum of opposites is always 0. Minus, now I have a 4i squared, but i squared is -1. So this gives me a 1 plus a 4. After all that, it simplifies to 5. Now let's tackle the initial problem. So I'm going to look up above, and there it is. Well, let's just copy it again. It only takes us a minute to do this. Copy. Let's bring it down here. Paste. That looks like a good spot for it. So what we're going to do now is we can multiply this by its conjugate, because we already know what happens in the denominator. So negative 1 plus 2i. And the rule is, if we just multiply by anything by 1, we change its form, but not its value. So I'm going to just multiply this, turn this fraction here into just a big 1. Remember, that's what all of this is. This is just a fancy 1. So 1 times anything is just the anything part. So here we go. Okay, we already did the denominator. We know that that's 5. Right up above. So let's just write that 5. And now we distribute through the numerator. So I have a 3 times a negative 1 to get a negative 3. I have a 3 times a 2i, that's going to give me plus 6i. Then I have to get to my magenta. Let's use that. And now I have a negative 5 times a negative 1 to get a plus 5i. And then I have a negative 5 times a 2i, that's going to be a minus 10i squared. Okay, now we do cleanup. So extend that. Okay, here we go. We have, well, let's see, we have a negative 3. We have a plus 11i, combining the two middle terms. And then remember that I squared is negative 1, so this is minus 10 times a negative 1 over 5. Now, I realize that you may go through the steps a little faster, and that's fine, and that's a natural process of understanding, but I write them out each time so that you can see and so that we don't get ahead of ourselves or confused. So let's see, this is a negative 3 plus 11i plus a 10 over a 5. So I can combine this to be negative 3 plus 10 is 7 plus 11i over 5. And then we're going to do what we did earlier, where we broke this into its parts of 7/5 plus 11/5 I. And so now we have a real component is 7/5, and the imaginary component is 11/5 I. Okay, one more example here is this. Let's try, let's try this. We're going to simplify. And in this case, it's a division problem. Simplify 1 over I cubed. So 1 over I cubed. Okay, well, let's do this. First, before we even get started, let's just recall right off the bat. Recall I cubed is the same as negative I. We're going to just simplify it right off the bat. So here we go. I have 1 over I cubed. And I remembered that that's the same as 1 over negative I. Now, this is going to, it may look a little strange, but if I think that negative I, it's a complex number, it's the complex number 0 minus 1i. So it has a conjugate. It has the conjugate of 0, remember, plus 1i. Well, 0 plus 1i is probably going to be simplified to simply 1i, but 1i, the 1 is implied, so that's just I. So the conjugate of negative I is I. Okay, so our next step then is to multiply 1 over negative I by its conjugate. So I'm going to have an I over I, and remember this is just another big fancy number 1. So all it does is change appearance, not value. So in the numerator I go 1 times I to get an I. In the denominator I have a negative I squared, but then if I recall, I squared is negative 1, so this is I over minus negative 1. But a minus negative 1, well, that's I, or I'm sorry, that's 1, so I have I over 1, which simplifies to I. And that is how you divide complex numbers. Thank you for watching.